Hello and welcome to this presentation. We are going to be considering the design of this real-life reinforced concrete building project from modeling to detailed drawing using ProtaStructure 2026 version. If this is the first time you have come across a video on our channel, Surfacing Academy, consider subscribing, like, and also share our video with our colleagues. Let us get started. I will create a new project. From the File menu, I click on New Project, and I will save this project. In the project code provision, I'm having these 3 floors. I'll change this to 4 floors, and then I proceed to the code of practice. I'll be using United Kingdom Euro code as the template. Click on the OK option. Here we go. So the Euro code template is ready. We proceed to see the design information, which are the design data we'll be considering for this real-life project. The intended use of this structure is residential, and then we are using United Kingdom Euro code. And so these are the design stressed, the concrete cover dead load, other loads bearing capacity, and the type of foundation successfully. So we navigate to AutoCAD. In AutoCAD, this is the architectural drawing. So you'll find link to this architectural drawing in the description of this video to download it free of charge, so you can follow up this design successfully. So this is the panel. Altogether, I have 7 panels right here. So I will start to export this panel to the XF format of AutoCAD. So we'll first of all locate the origin of this AutoCAD environment. So by typing L on the keyboard, enter, and then you type 0 on the keyboard, comma, and 0 again, and enter. So this will locate the origin. You can see this is the origin. I will click Extrude, come over to the panels. I will have to copy from this point and then take it to the AutoCAD origin, just like this. Escape. I will delete the reference line, after which I will select all of this. Structural panel, W on the keyboard, enter. So in the right block window, I will click in these 3 dotted provisions. This will navigate me to a new folder, and then I believe this folder is on the desktop. Alright, so I give it a name as a building plan. Okay, but this time around I will change the AutoCAD format to DXF, because ProtaStructure can only read the XF format of AutoCAD. I click on save to save it right in the new folder, and then the unit instruction is millimeters. It should be properly selected right here. Click on the OK options to have that plan saved successfully. Then I will navigate to ProtaStructure. Okay, I go straight away to the modeling tab, and then I will have some informations right there, but just go to the building setout where we can import the DXF file in this provisions. Click. So this will take us to this DXF import window. Just click in the load DXF, and then this has taken us to the desktop and to the folder. So in your own case, you can navigate to wherever you save it. This is the plan right here. I click on open, and this has opened. So you can see the layers that I have right here and the ones that has been added, including wall, but I don't have wall right here, so I have to uncheck that. Okay, so every other things here, leave it positive. Click on import from here, and then the old plan and the columns will be imported successfully. I click on close. Okay, so here is the grid line set out and the column positions for this project. Okay, if you zoom closely, you can see my column sections is 300 by 225 sections, okay, that I'm using for this project. So we proceed to generate stories. So we have up to 4 stories. So I'll click in these provisions, right click, and then I navigate to edit story. From here, at default, the story height is 3 meters. Okay, so I want the story height to be 3150 millimeters, just like this. Okay, and then the foundation depth, I'll set it right away from here. From the design data, we have foundation depth to be 1500 right here. Okay, so I will use this option of assume roofed as normal story. When we get back here, the structural system should be ROC. I click on the OK option, and then I click in this provision again, stories, right click, and then I can click on insert stories. Right away, I will be having 4 stories. So you can see in the structural tree, I have the 4 story right here. Navigate to the populated story, which is the ST1, where I have my columns. And I will get back again to the edit stories. So I will make the first story and as well as the second story to be similar by defining selected story as similar in these provisions. You can see 2 and 1 as similar. All right. And then the structural system is ROC all through. I click on the OK option. After which, I will now start my modeling. To start my modeling, I navigate to the modeling tab and I save this project first. I'll start from beam. I select the reinforced concrete normal beam options. I will having my beam sections to be 225 by 450 for the first floor and as well as the second floor beam section. Okay, after which I will just have to do a window over the columns point, release my hand to have the beam placed just like this. So I'm actually placing the beam or inserting beam along the external. Okay, so after which, after the insertion along the external wall, I will proceed the internal partitions. Escape from the keyboard. I pick these columns and select it from here. So this is what the panelings and how they are arranged. So you must ensure you zoom closely so you can be able to pick the column points correctly. So I think this is the paneling that we have in AutoCAD. We can navigate to check that in AutoCAD from here. Okay, we have altogether 1, 2, 3, 4, 5, 6, and 7 panel, and this is the steer room. So this is just like a cantilever. Okay, we will incorporate all of that. So let's get back to ProtaStructure, and this is 1, 2, 3, 4, 5, 6, and 7 panels successfully created. Okay, so having created this panel, we proceed, navigate to 3D. So here is the structure. So you can see, because it is a similar story, we have the beam populated to the 2 floors. Navigate to the plan view. We want to start to model the reinforced concrete slab. So we have to also navigate to the design data. So for the reinforced concrete slab, we are having the finishes to be 2, and then we have partitions right here to be 1.2. So 2 plus 1.2, we have 3.2. all right, so this one is the slab thickness and the concrete density. All right, so for the slab concrete cover right here, for the slab concrete cover right here, we have it to be 25 millimeters. All right, so let's get back from here. To model the slab, you have to create your loading combinations. So you go to loading tab and click on load cases and combination options, loading generator. So from here, we'll be considering we load. Okay, and then we have all of the vertical load defined successfully. Click on the OK option and then click on OK again to close the dialog. Then we navigate, save the model, modeling tab, this reinforced concrete slab. So in these provisions, we have our slab thickness to be 150 millimeters. For the concrete cover is 25 already. That's what we have in the design information. We proceed to the loading provisions. Okay, this is 3.75. For additional dead load, we have it to be 3.2 from the design informations, and then the imposed loads. This is a residential structure. We have it to be 1.5, just like this. So we click in this provision or in the panels to have the reinforced concrete slab instructed just like this. Click on the closed options. We need a beam here to support the staircase. So I'll click on this normal beam, and then I still have the same sections. I pick the first point, pick the second point, escape to have that beam. I will select on this particular slab, right click and use its property. So I can have a reinforced concrete slab right in this small panel. Then I want to proceed to model the staircase, but before then I will have to navigate to the ST0 so I can be able to model the sub-base beam. Alright, so for the sub-base beam, we click in this beam provisions, and then we have foundation beam and then sub-basement beam. Okay, sub-basement beam, select on that, and we defined the beam sections as 2 to 5 by 450 as well. So after which, just do a window over the columns point, click to actually insert the sub-basement beam. So you continue to insert the beams. So make sure you are actually insert the beams from the green line intersections. Okay, I think this is good. I'll close this, navigate to the 3D right here. So this is what we get for now. So we get back to the ST1, which is the story one. Navigate to the plan view so we can model the staircase. So for the staircase, you use this staircase provision. So in staircase modeling, we have 3 options. First is by selecting the area, just pick in the area bounded by the beam or in the panel or in the stair room. Okay, second option is using 2 diagonals. Pick this first point, pick the second point. So let's use this second option. So we learn how to use that. I pick the first point, just have to pick the second point just like this to have the stair window just like this. You can see. So from the stair window, we have various types of staircase here. We want to use the the U-shape stair. Okay, so I have to pick on that and start the modeling. I pick the first point, pick the second point, third point, and the last point to have the stair placed successfully. So over here we have the geometry of the stair. Right here we have the landing width, straight width, the flight length, so the width thickness, landing thickness. So this I will change to 150 millimeters, 150 millimeters, just like this. So having changed all of this, also you can use the alignment to align the stair outside just like this or inside. Okay, so this alignment is okay, and as well you can revert it should in case you want the upper landing to be by your right. You can just use the reverse directions. You can see reverse directions. So these are the very intelligent tools that you can use to make those changes successfully. Next, come to the load provision. So you have the dead load from here. So I'll just use a room load of 2.38. For the live load, I'll just use a domestic load or residential building load, which is 1.5. Okay, click on the OK option to insert the stairs. So this will be inserted actually all through the stories. If I navigate from here to 3D, you can see we have our stair properly placed just like this. All right, so now we proceed to model the other two floors. So to model the other two floors, what you do is that you have to navigate to the second floor right there, and then you get to the plan view of the second floor just like this. So the area of concern for the next floor is just this provision, so we just have to select the consigned provision including the stair. Okay, just like this, select this. Okay, also select this particular reinforced concrete slab, the beams, as well as the reinforced concrete columns, just like this. So this is the provision that we need at the next floor, which is the third floor. Okay, so having selected it successfully, you have to check closely to make sure all the part that you actually need in the next floor is selected successfully. After which we navigate to the building set out, and then stories and story operations will generate this to the third floor only. Okay, so over here selected members only is check. Click on OK options and yes options. So that has been generated successfully. Click on the OK option, and this is what we get at this level. All right, so if you navigate to 3D from here, you notice you have this at this level. Okay, so I haven't gotten this at this level. Okay, so the next level, we are only being consigned with this this part. So let's navigate to the plan view. So the part we are consigned at the next level is just this part that we are consigned. Okay, so having selected this successfully, you just have to proceed to the building set out stories, and then you generate story from here to the fourth floors, and from here you click on the OK option to generate that successfully. Click on the close option. Now you can get to the 3D. Okay, so this is the model. I think we have gotten it correctly, but at this level now we wouldn't have stair, so you have to select on the stair and then get rid of it from here, after which you select on the reinforced concrete slab as well, and then we can easily get rid of that. Click on OK options. Okay, so this is what we get from here. We proceed to model the cantilever slab, so we have to navigate to the ST1 and then right click and get to the plan view of ST1. So we have a cantilever slab here of length 1.3. so we just need to get to the modeling, save this project, and then navigate to reinforced concrete slab right there. Give it a thickness. We need it to be 150 millimeter thickness. Concrete covers 25 millimeters. All right, so for the load from here, we consider it to be 2.3, right? Okay, 3.2. that is the load we add on the design data. All right, 3.2. for the imposed load we use 1.5. Get back to the general tab, and then the slab type is going to be 12. Come to the cantilever provisions. The L count is 1300 millimeters. From here we apply the load of 5 kilonewton per meter for the balustrade successfully. Just pick 2 points, move your hand outward and click to have it inserted just like this. Close this window. So I believe this has been inserted in the second floor as well. So if you get back, you can see this. So this is what we model. So after which we want to proceed to get rid of the stories that we actually made similar. So we get to the stories option, right click, come to edit story, we want to get rid of the story we made similar. So what do? We have to reset this from here. Having selected the stories, the first and second, we'll reset it to get rid of the similarities. Right there, everything is good. Click on the OK option and yes option. Okay. At this point, we'll start to load this structure. Before the loading, we need to provide reinforced concrete slab at the sub-basement beam level. So we navigate to the ST0 and then get to the plan. From here, navigate to the reinforced concrete slab. The thickness is going to be 150 millimeters, carrying descent cover. And then we applied sub-basement slab options and applied Z to analytical model. So just like this, we'll be inserting it using the beam region options. So just click in the panel provisions to have the slab inserted just like this. So we are done with this. Click on closed. So for the load, we navigate to the 3D. We're going to be loading this using the 3D. Okay. So what we do, just select one of the beams. From here, you can click on edit load, or you can actually go straight away to loading provisions, move the green line to the floor you want to load, and then you click on the load editor option. So that will navigate us to the load editor, showing all the beam at the floor. All right. But I already want us to use this process. So these are the loads applied on the reinforced concrete slab, is what you are seeing right there. Click in this provision, click on the OK options. I'll go by selecting a single beam and then click on load editor. So I have only that beam, just like this. You can see we'll be considering wall load. So from the wall load, we have a wall height of 3 meters. So I will reduce this wall height to 2,700 instead of 3 meters. The reason is because of the beam depth. Okay. So for the wall unit weight, this is going to be 3.47, just like this as given in the design data. All right. So I just have to give a thickness of the wall to be 225 right here. It's very important. And this load is classified as the G load or the dead load from here. So you can see we have G load, Q load, WX and WY are the main load. Okay, but our concern right here is the G load. Okay, which are the wall loads. I pick on the beam right there, just like this. To have the wall load applied, I can disable the infill wall to actually have the rear wall itself, just like this, and the total load amount 15.42 kilonewton. That's the volume. All right. So from here, you can choose to use these provisions, edit opening to open. All right, but I design just like this for the sake of unforeseen circumstances. Okay, I click on the OK options to have that applied successfully, just like this. So I have to just select the first beam right there, and then select on the last beam by holding down the shift key right here to have all the beams at that level selected. But before then, you need to copy this load to clipboard. So you can use the option of copy load. You can see option here, copy loads. Click on the OK to have it copied before you proceed to select the beams. You right click and then use paste options right here, or Ctrl V to paste the load. Copy it successfully. The same thing applicable here at the first floor. So you want to navigate to first floor right here, expand the beams, select the first beam right here, scroll down, hold the shift key, select the last one, right click and paste the load successfully, just like this. All right, so at this level, we want to apply the load, but we are going to be using a line load right here that will cater for the that will actually cater for the balustering work activities that will take place along the beams. right here. So what you do, click on save to save this model, and then we click on this point line and area load. We use the line load, so we provide a load of 8 kilonewton per meter run. So this is actually going to be a G load, so we have to pick first point. You see, picking it is not actually working properly because the grid line is not at that level. So what you do is that double click on the ST2 right there, which is the second floor, to move the grid line successfully, and then get back to the load provisions. We choose the right load right here, key in 8. So now you can pick the point right there, pick the second point to have the load applied successfully. So we can zoom closely to ensure that you get the right point selected. So you can as well do this in 2D. You get to the story provision and navigate to 2D. So you can see the first one we applied right here. So I can select on this, right click, can use its property from here, pick this point. I don't think this is properly applied, so it also applied right here. So just have to undo first. Select on this, right click and click on the property again, zoom closely, pick that first point and then pick the second point. So we're having this load apply just in this direction because we use this property. So what you have to do, just delete this up and then click on the line load again, navigate, and then click here, give it 8 kilonewton per meter, and then you draw it. So now it's properly placed. So have it right here from this point. That is placed properly. From this point, we take it to this point to have it placed also from this point all the way to this point right here. That is good. Click on closed. I think we are done with that. So navigate to 3D to have this load placed just like this. So we need also a load at this level. Okay, so what we need to do is we just have to first of all select on this wall load, right click and then click on copy load, close, click on OK options. So we need to select the consigned reinforced concrete beams to apply this load successfully. Just like this. So you can right click and paste the load just like this. Alright, so over here we also need a line load. We move the grid lines to that story, which is ST3 right here. Then navigate to the plan view. Okay, click on the line load right here and 8 kilonewton per meter. Pick the first point. That point is wrong, escape. So this is the point. Second point to have it place first point. Second point to have it place first point. And second point. Closed options. Navigate to 3D. So this is what we have. We also applied the wall load right here to the consigned reinforced concrete beam. So just hold down the control key on the keyboard to select multiple reinforced concrete beam that you wished to actually apply the wall load from here. Click on there first load to have it applied successfully. So you can see we need a load on this pin right here, so you can paste the load right there. Okay. So this is what we get right here. So if you notice, you can see that we wouldn't have shear from the ground level. Wouldn't have shear from the ground level right there. Okay, so we only have stairs from the first floor to the second floor, but from the DPC level to the first floor we did not have a stair. So move the grid lines to ST1, okay, which is the first floor level, and then navigate to the plan view of the first floor level. Just like this, you see there's no stair right here. We get to the modeling tab, click on save to save this model, and then stair provisions, pick the first option, click here to have the stair dialog, the U-shape options, pick the first point, pick the second point, the third point, and then the last point right here. Have the stair placed successfully. I'll change the width thickness to 150 and also the landing thickness to 150 right here. Alright, everything is good. Click on the OK options. That has been placed successfully. And then navigate to 3D from this provision. So this is what we get. We're now having the complete stair system right here. So we have a cantilever right here as well. So we navigate to the plan view. So we can insert the cantilever slab along this length 1200. Click on the reinforced concrete slab right here. Or you can choose to use the property of the slab. So you wouldn't change these properties again. Just change only the type of slab and then come to cantilever provisions and type 1200, which is the cantilever we have right here. We applied a load of 5 kilonewton and then we have that inserted successfully. Click on the save options and then navigate to 3D from here. Alright, so we can see this is what we have. We are done modeling the structure now. We have also loaded the structure successfully, as you can see from here. Alright, so it is left for us to apply the wheel load. Okay, so for the wheel load applications, we click on the analysis options. So you can go by the building analysis right here, and then you see wind load and story load, or you can just get to this building. You can go to loading option. You see wind and story load is the same option. So this will take you here. So if you expand these provisions, so you can see for the W, X, WY, the values right here are actually in kilo newton, in the FX, FY, and then kilonewton meter for the moment that the wind will generate. Okay, and all of these provisions, you can see they are all zero because the wind has not been applied successfully. So you have to click on the wind load calculator right here, and then you have this interface. So I'm using a wind load of a wind speed of 45 meters per second. So what would be my wind pressure? Okay, so from the wind load you obtain your wind pressure. Okay, so you are going to be squaring this 45. So let me bring up a calculator so we can do that together. So from here you just have to type in 45 square. This is equals, give us the 2025 right here. So this 2025, just have to multiply it by 0.613. Alright, equals. So from here I have 1241. Alright, but this is in kilopascal. Alright, so you have to divide this by 1000. So divide that, I have 1.2 right there. So the wind pressure is going to be 1.2. Okay, in 1.2 right here. So after which the primary wind angle is 0, and then the building categories is reinforced concrete. There are other structure right here, and then from the terrains and surroundings, it depends on the site location, whether exposed to the atmospheres, tall structures in those provisions. So we just go by this default terrain and surrounding. Okay, so click on the apply from here. So now if you expand these provisions, you can see that we're now having the value for the FY, for the MZ being provided for all the floors successfully. Click on the OK. So this load has been applied successfully on the reinforced concrete model. I click on save options from here. Alright, so if you click in this provision of settings, or you navigate to building setup and click on settings center, it is the same thing. Okay, this is just like a quick access tool. Okay, click right here for the settings, so we can navigate to set the foundation. But at first, here are the codes we selected earlier. We use a Euro code for the design of reinforced concrete structure. Euro code 2 right here is used. Okay, so we proceed with the foundation design right here, and then the allowable soil bearing capacity from what we have right in the designed data. We have 220 kilonewton per square meters right there, and then our foundation depth here is 1400 millimeters. Okay, so let's get back right here. This is 220. All right, then from what we have here, you can see that the lane increment is 100 right here, and then the street footings cantilever. Okay, we are not designing street footings. The pedestals, we don't have anything to do with that options right away. We check the design options right there. You can see we have a rectangular footings right here. So you can take the program. I want all my footings to be squared, so that during the design, the program will assume square footings and distribute the length successfully. So the minimum footing width right here is 1000 millimeters. So I normally use a minimum footing of 1200. So this is what the program will consider. So the minimum part base depth, I will try 350 from here. The maximum part base depth, that's not a problem. I'm seeing 2000. You can get this. Okay, but you can just leave it. All right, we proceed. And then over here we have building analysis source. We have the FE, and then we have a building analysis itself, but we can't actually analyze both at the same time. Okay, I'll show you how to do that as we make progress. So the steel bar selections, leave this provision at default, and then the steel bar space, which is the maximum steel bar space, I will use 200 right here. I really want it to be 250. Okay, over here I use top bar, so I can decide to uncheck here, but I will correct this later. You see how I'll do that. Okay, after analysis and design. So the minimum foundation depth to use sidebar is 400 millimeters. Okay, so which is the one we have changed from here. We can be able to use sidebar right here, but you know, we reduce it to 300, so there will be no sidebar, and it's not going to be a top and bottom footing. Okay, I will make changes. I wouldn't want to change it from here, but you can change it from here, so it can give you a single reinforced part base. Okay, all right, come to the steel provisions right here. There's nothing much to make changes, but for the maximum distribution rebar space is 250, so we can work on this, make this 200, and the maximum rebar space right here is also 200. We'll make this 200. For the minimum rebar diameters, we have 8. We'll make changes to all of this as we make progress. So for the bottom rebar bob length, okay, this is good for the concrete cover. For what we have in these provisions, the concrete cover from here, we have beam staircase to be 25. Okay, so over here we are having concrete cover to be 20, so we change that to 25. All right, so this is okay for the stair. All right, so can we look at the beams? Not now, we'll come back to beam later. Click on the OK option and then save this project. So now we navigate to the material settings from here. Click on the material setting. So from what we have, what is the compressive strength of the concrete? From here we have 20, 25, and then we have the Fy, the steel will be 410. All right, Newton per millimeter square. So let's get back to these provisions. Here we make the changes. Click here, and then we have 2025 options right there. We applied it to all of the structural elements. Click on the OK options. The steel grade right here, we have 410 right there. We applied it to all of structural elements. So from here we can edit the rebars diameters. Click in the edit provisions from here. So for the first concrete column, the minimum rebar will be 16 mm diameters. We don't have wall in this system, we have beams, so the minimum reinforcement diameter will be 16 as well for the reinforced concrete beam. For the slab, we have our minimum to be 10. Also check 12, we get rid of 13. So for the staircase, we have 8, so we check 10, 12. All right, and then we have 16 right there. So for the foundations, we have also 12. Sorry, we have 10 here, 12 for the foundation. Remove 13th, and then we go by 16th right here. Diameter reinforcement. For the links, we want to be using 10 mm for the links. Okay, so I'll have to select between 10 mm and 12. Get rid of 13. You can get rid of the rest or you leave it, because the program is going to actually start from the minimum to select the reinforcement. Okay, for the tension rebar for the columns, we can also use minimum of 12 right there. So this is a link, so use 10, just like this. Okay, so with this you can see that we have actually select our preferred minimum reinforcement diameters successfully. After we click on the OK options and then click on OK again. So the changes is done. Go to the foundation floors. So we change this as well. Applied it to all. Click on the OK option. This has been applied already. Okay, so for the foundation right here, I'm still having 25. So you have to change this to 20, 25. Apply that OK. You change the grade as well to 410. You click in the edit. I think everything is good from here. Click on OK options, but apply this to all successfully. Over here for the links, you see grade 500. You have to change this. For link, we also use 410. Apply it. OK. So if you have any question, you can drop it in the comment sections. All right, and then if you check in the description of this video, there's a group chat you can join to ask questions on this reinforced concrete building design, steel design, and other civil structure. Okay, now for the soil right there, I'm seeing sand right here. So we have clear, we have sealed. So this has to depend on the soil report. Okay, at the soil layers where you wish to anchor your foundations, so depending on the soil properties. Okay, so we go by sand. Okay, so these are the informations for the sand. We can add as well from here if you wish to add. Okay, click on the OK options. Then over here, if you come down, these informations are for the steel structure. So you click on the OK option, save this model. Now we navigate to the settings again. This time around we get to beam, and then what we are having here is H. Sorry, that is not what I want to actually check. Get back to design, parameters. This is what I wish to check for the beams. We must have the minimum beam steel diameters and the maximum right there. Based on our selections, we have this. Okay, all right. So the links, we have this. Okay, this cannot be a links, but that is not a problem. Y20 cannot be a links, but that is not a problem. The program is going to select between these two, 12 and 10, and it will select the minimum. All right, so that is why I wanted for this structure, for this design, the length should be 10 millimeter diameters. That is why I have to select that. Okay, over here we also have the steel bar properties, minimum top rebar space. This can be arranged to your own desired length. So we have the steel bar space step, and then we have the steel bar cut length. This is always 12,000 millimeters. Okay, link properties are also here. The spacing, you can see maximum space link is 300. I would like this to be 300. Okay, for the foundation beam, so we still have white wave to be used for the foundation beam as the minimum right here. Okay, that is not a problem. So for the concrete cover, you can see over here it is 000. This simply means the program is going to use the concrete cover based on the code. Okay, so that will be fine. All right, so that is all about beam. Come to columns, there's no much change, there's no more changes in the column provisions right here. All right, we don't have much changes here. Okay, so we go to the project preferences. So here you need to feed in the designers, the check, the drawn by, presented by. All right, so this is the project client, project title. So you have to feed in these provisions so you have them on your calculation sheet. Is very, very important. Okay, all right, so we proceed. Click on the OK option and save this model. At this point, we'll just have to check the model. If there is any error from this provision, click on checked. We start checking if there is any modeling error right here. So you have 0 error. Click on closed. So we are good. All right. So for this roof beam, I want to be reducing the beam thickness or the beam depth of this roof beam. So what I will do is just have to navigate to the last floor, which is the ST4 right here. Expand the beams provision, select the first one, or the shift key and select the last one. So you have to right click and then click on the properties. So in this property, click in this provision, and then we can now be able to edit this. So we edit this as we use 350 right here to reduce the volume of the concrete. Click on close right there. Okay, this is nice. I click on save options to save this model. If you navigate to the plan view, I will show you something now. If you navigate to the plan view of this structure, you can see that we have grid lines not really very much arranged. You can see so, but you can select this and then you click on the grid line properties to be able to make changes and arrange them in this provision successfully. All right, but we will not be doing that because of our time is running out. Okay, so after which we can get back to the 3D so we can see what else we need to add to the structures that has not been added. I think everything is added. All the loads has been applied successfully, the wheel load, and then all the live load has also been applied. Okay, so if you want to apply it any machine load, maybe you want to have some machines or some serious activities at this floor, like this floor will be having some activities going on. There will be crowd around here, all right, or people playing around. It's a residential structure actually. Okay, but this can be a playground, so this slab has to be applied an additional load. So what you have to do, navigate to that level, which is the ST2 right there. Then you get to the plan view of ST2. So I think this is the provision. So if you want to apply an additional load right here, what you do is you can double click on this particular slab and then add additional dead load here. Originally we have 3.2, so you can make it maybe 4.2. All right, that is one way to apply it, the load for a specific panel slab in a panel. Okay, that is the first method. The second method is for you to use the line load, and then use this area load. So since it is an area load, you have to be careful of the magnitude of load you applied. So this is going to actually be a live load and not a dead load. Okay, so we get rid of this. Can have a live load of 0.1 kilonewton per square meter. So you just pick the first point, then sorry, I hope okay, the first point, pick the second point, move your hand this way and pick the second point to have the load placed just like this. So this is a load of 0.1 kilonewton live load right there to be incorporated into the loading combination successfully. So just pick the 2 points, the first point and the second point. Sorry, this is not properly placed. I will undo that. Okay, so I can select on this, right click and then click on its properties. The 2 diagonal points, you have to place it just like this. So there is a warning there that the load is not properly placed, it's falling out. So just have to get rid of that. Picked it, it should be on the slab. All right, just like this. Okay, should not get to the beam, so you won't have that warning. Okay, so this is how you can apply. We have an excess load here. So just right click and delete it from here. So now click on save options and navigate to 3D. So you now have all of this load right on the slab panels successfully to cater for the unforeseen activity that may be taking place here. Okay, we are done with the loading application. Let's proceed to the analysis tab. So we go first by building analysis provisions, and then you can go to these options of you don't need to edit material. We have done that. Just come to the model options right here, and then you also need to come to the let's look at the slab model provisions. You can see over here include slab in building model. This is the finite element. So as you are running the normal analysis or static analysis, the finite element analysis will also be applied successfully. So you can see include column sections in FE, used to decompose slab load in mesh story. So you can actually be able to select the number of story you wish to apply to the finite element. So over here it's only just one story. I can apply it to up to these 3 floors, first, second and third, successfully. Okay, so over here we see include column sections FE. We can also use the load decompositions to slab, but I wouldn't want to apply that. Okay, so over here to the settings, we don't have anything much to change here. Column outline modeling for flat slab, we don't have that slab system. Okay, for the wall right here, we wouldn't have wall, otherwise final element is also selected right here. You go to the model. Okay, everything is nice. From here, go to analysis. We can check the building again. If there will be any modeling error, we have 0 error. Click on the close options and then building analysis from here. So I want to analyze these reinforced concrete columns and as well design it. So that is why I want to check all of these provisions, including the beam members. Click on the building analysis. So give the program some seconds to actually carry out the build analysis and as well design all of the structural elements and select the right sections successfully. you just have to click on close option because analysis is done on the structure. So close it from here. So now you can see that this has been analyzed. You can proceed to the analytical model right here. So you can see the analytical model. So here is the analytical model, and then you can actually see the animations and the reactions of the staircase. The reaction of the staircase with the building system successfully. You can increase the scale for the animation right here. You can see what we are getting. So we have some mesh for the finite element at the first, second, and the last floor successfully. Okay, so we stop this and get back to the physical model right here. So we now start to carry out the finite element analysis for the foundation design. So we move our gray lines to the ST0 right here, and then we click on this FE foundation analysis. So right here we check these provisions, and we are going to be using the plate element size of 500 and 1000 maximum. Okay, after which click on the floor mesh and analysis. So here is the sub-basement slab and the beams. Click on the OK options. Click on the OK options. So that has been analyzed successfully. We go to the display analytical model provisions right here to carry out the design of that floor. I mean the sub-basement floor. So this is what we get. So this is being offsetted a very distance just like this because of the scale we use right here. All right, you can see the scale has been reduced successfully. Okay, so if you click on the animations, you can now see the animations right there. We just need to get to the contour tab, and then you have to contour the floor, and then you apply the forces by clicking on this provision. Just apply the moment as well by clicking right here. Required area of stairs we show we have 27.76 right here. Required steel area, just have to select on that, and that has been analyzed. The steel will be selected automatically, so we'll all learn how to draw the steel successfully. So after which you just have to navigate to the physical model. Right here we are good to go. We proceed to the foundation beam right here. So here you have foundation beam. We need to analyze and design the foundation beam. So you can see the foundation beam has not been analyzed. Has not been designed. So we click on this beam design batch mode. We will select all bar, click on calculate. All right, so here we go, click on the closed. So you can see all of the beams. All of the beam has been designed. So what you just need to do is to do and carry out interactive design for these beams successfully. So the foundation beam is designed. Click on closed options. So let's navigate to the first floor beam. Let's see how we can interact with one or two beams so you can learn. Okay, I click on save options, and then I will expand this. I select on this, right click, and then I will use this option of active stories. So I can see only the beams in that story. The first one is selected. I click on interactive design, and then you can see that I have some mixed up reinforcement diameter. You have Y20. I have also a Y16 being used for this beam. Okay, but what you just need to do, you can just decide to use only Y16, but you have to change the number to 3 right here, and then this is Y16. This one is also Y16 to Y16. So it all depends on the area of steel you're having. If the area of steel is too small, less than 100, I would encourage you to increase the numbers of reinforcement so as to increase the area of steel for for a proper and stable design. Okay. Alright, so from here the links are sparse design as well. If I move this towards these directions, move it to this end, I'm having Y20 right here, change it to 316 like this. Okay, so all the Y20 you can change it to 316. It is also very good. We don't need web bars, all right, for this particular beam, because we have a depth of 450. We don't need web bars. We just need top compression and tension bars successfully. All right, so this is okay. Can click on the OK options right here. So likewise, all the beams you can be able to, do the interactive design. Go to the grouping provisions here. You can be able to group the beams within, you see, group beam axis within floor. So if you select from this provision, you can apply it to an on group beam. So if there are beams that are similar, it will be grouped together as a single beam. So the same thing we have done here, you're going to do it to all the floors successfully. I click on the close options. So you can also click in this provision and use this option on RC beam for the old structure. Okay, this is for the old structure, and you can see some of this beam has passed. The one has failed. No, not really failed, but the one we grouped, because we grouped it, that is why it is showing this red crossed. So just use the interactive design to redesign it from here, and you can see that everything is good, but it is still selecting this 20 diameter reinforcement, which I don't want, so I have to change it just like this. If I click on the OK options, you notice that it has passed design now. Okay, and then these ones that have U ratio 1, you have to also reduce the just the one we change. You can increase the reinforcement diameters. If you go to the bar provisions, increase the reinforcement diameters to numbers of reinforcement to 316. Just like this for both tension and compression reinforcement. We'll make this 316. So now if you check these provisions, you can see that we have 2.6. This is 2.6. This is a very small area of reinforcement, okay, at this support. So what you just need to do, you need to add a support reinforcement here. You can add 216 as a support reinforcement to correct that successfully. So let's check the area. So your attention should be on the area of reinforcement. So this is good. Now click on the OK. Let's see what we'll get. See, we have 0.83 as view ratio. This is fine. So what I've done now is what you're going to do to almost all the beam to interact with all of the beams to ensure that you have an economical and safe design. Okay, after which you click on the close options. We are done with the beams successfully. Let's look at the reinforced concrete columns. So just have to navigate to any of the columns right here, right click, and then we want to see all the columns in the structure. So expand these provisions, and then you see this as shown sign of failure, but the U ratio is good. So let's check what is the problem. So from here we can just do the interactive design. So you can see the steel ratio limit exceeded. So you click on the OK options. What you need to do first, try to increase this as column sections to 350, and then you click on the update and carry out the interactive designs. This has given us 6y25. Click on the OK options at 0.6. all right, but I think 6y25 is quite high for me, so we can manipulate that using these provisions. Can change it to 20, and I'm having U ratio 0.9. that is serious. So these provisions, you can just leave it 25. The second provision 20. This has failed. The first provisions use 25. That has passed. Okay. So at the four corners, I'm having 25 diameter. At the intermediate, I'm having 20 right there. Okay. So I can click on the OK options right now. So this will nullify the build analysis. I will say no. Alright, so that has been applied successfully, but the build analysis is not nullified. Alright, so making changes to column sections and making changes to rebars in the column after analysis will not necessarily nullify your build analysis. So that is another new update in this ProtaStructure version 2026. Okay, in the previous versions, if you make changes like that to columns, it will nullify the analysis. Alright, so that is a good one. We are good to go. You can work on this interactive design successfully on each of the columns and see how to make them properly designed in terms of reinforcement diameter. I'll close this window right away. From here, you can get your reports. Okay. Here we go. We are done with columns. So we proceed to the staircase design. So over here, click on the staircase design right here. So we have 1, 2, 3 staircase in this building system. So we just click on this bash mode options to design the staircase. So you see, design started as passed. Click on design, select the first one, click on design. So you can see the U ratios right here, and then the statute right there. So from here you can print your details report for the stair successfully, these provisions. Click on the OK options, and then click on the OK. We are done with stair design. Okay. Now we proceed to design a reinforced concrete slab. For this reinforced concrete slab design, you just have to select this slab, right click, and then we need to set slab type automatically. So we apply to all slab in the story. So we use these options. All slab in the model, click on the OK options, and then click on the OK. That has been applied. Alright. So before we carry out the slab analysis and design, we need to actually draw the slab strips. Okay. So for the slab strips now, we navigate to the ST0. We start from the ST0 to draw the slab strips. So navigate to the plan view of the ST0 just like this, and then you can just move straight away to save this model and then go to the modeling tab. Use this option on slab strips. Okay, so we run in the X direction first. So the analysis tab we are going to be considering at this level is a finite element analysis. So we use these options of span strips. Okay, so we use FE. It's going to be out to out right here. So we scroll down. Over here we used, instead of the foundation slab, we use the sub-basement slab options right there. So after which we proceed to pick the first point. If you pick the first point from here, and then you proceed, hold the control key to have a straight line, pick the second point to have a reinforcement being generated successfully, just like this. So we do the same thing across the spanners. So you can see that the section is insufficient. We have section problem right here at this level. So we have section problem FX3. Take note, click on the OK option. So this will not draw the strips because the sections of the slab here is not sufficient. Okay. So, and then the program said is this section actually. So what we'll do, let's see if it is actually that sections by getting back to strips again, and then we use the same options we had right there. Let's draw it for just these two panels right here. So I will hold the control key and click right there. So it is drawn right here. So this is the sections we are having issue with. All right. So what you need to do here, increase the thickness right here, but this is resting on the soil. You don't really need to increase the system because this is not suspended. All right. So what you just have to do, leave it the way it is. It is resting on the soil. It's already supported by the soil all through its area. All right. Unlike the suspended floor. Okay. So now what you just have to do, change the directions from here, and then we'll go to the Y direction, pick the first point, hold the control key, and then place the the slab. Let's see to design in the y directions if it will pass. Okay, it has passed in the y direction. It's only in the x direction that is giving us that insufficient slab thickness. So for this particular panels, you just have to start it from the slab, from the slab and end it outside. So this is the slab. You click, you end it outside just like this. So this is how you manage the boundary conditions right here. We are done with the strips at this sub basement slab successfully. Click on the close options. So we navigate to the first floor. Now you can carry out the slab analysis right at this level. Okay, but let's finish it up before we go into the analysis. Double click on the ST1 and then here is the slab. So we proceed to draw the strips right here. We just have to click on the strip now. This time you're going to be using analytical strips at this floor. Okay, so analytical strips right here. There's no options to update anything right here. So just have to draw analytical strips. So we use Bob as the boundary condition. Pick the first point, hold the control key to have a straight line. Okay, just like this, and then you click to have the reinforcement successfully in the x directions. Let's try. You will have a section problem as we had before, and then you just click. There is no section problem right here. So you start here from the slab and then end it outside, which is for this small panel right here. So we click right here to have that place. You go in the y directions. Okay, pick the first point, use outside as a boundary condition. Okay, and then you click right there to have it placed. So here we have a cantilever right there. So what you do is you have to start here and end inside cantilever. That is the option. Pick the first point, move your hand toward the direction or the control key and click. You can see, so the cantilever is being detailed successfully. You can see the reinforcement provisions right there. All right, so now we start from inside slab and end it outside, which is for this particular panel. Okay, so we start from outside and end outside, which is Bob. Okay, we have cantilever here as well. So what you just have to do, you start from outside and end it inside the cantilever. So we pick these provisions and then come over to this side, or the control key to have a straight line and clicked. So we're having x1 section insufficient. Click on the OK. That will not be placed, which is x1, so we check which is x1. Okay, this is x10, this is x1. This one in this direction, the section is insufficient. So once it happens this way, nullify analysis no. So once it happens like this, what you just have to do is to increase the slab thickness. I don't want to nullify this analysis. All right, so just increase the slab thickness. All right, and then we run the strips again. It will pass. And then you have to take note of this particular panel during constructions to ensure that it's being implemented properly. All right, because it is actually falling in the y direction. You see the x direction strips has passed successfully. Okay, here we go. We can now proceed, navigate to the next floor. So we could have done it for this floor as well as this floor. All right, but with the same method we have used on this floor, just applied it to the other floors. Okay, and then you are good to go. Click on the save options to save this model. All right, now click in these provisions. Now right click and carry out the slab analysis and design. All right, so over here you can use this option of batch mode. You can delete and reselect all bars. Click on calculate. That is finished. Click on the close options and then you have your U ratios successfully, and then this particular one is failing, the one that had issue with the x1. All right, so now as I said earlier, increase the thickness right here. Okay, we are good. Everything is designed successfully. You can print the report using these provisions. So I want to close this for now. We are done with the slab design, so we get straight away to the foundations design. So for us to do that, we can't do that in 3D. We want to actually carry out the foundation design at once. So you just have to select all the or the column just like this. But you see the green line is not at the foundation, so you have to move the green line to ST0 just like this, and then select the reinforced concrete columns to be able to have insert pad footing options. You can see insert combined footing options, insert pile cap, insert combined pile cap right here. So now click on the insert pile footing options from here. So this will bring up the pile footing window just like this. All right, so this is what we get at default. It is actually loading. Okay, so this is what we get at default, and this is the depth. I thought we have made changes to this depth. So if you come to the foundation settings provisions, you can be able to see these options that we have actually made changes to before. All right, so we are considering minimum. You can see minimum depth of 350. All right, just click on the OK options, and then for the reinforcement settings, we can also work on that. Okay, but let's just go by the one we have done before. So we use the option of design all, and then we click here design all. So give the program some second. It's going to design all the footings. Alright, the footings has been designed, and then the you can see the spacing for the reinforcement is being maintained successfully. And again, you can see we have 1.4 by 1.4. The square footing LSLY is being also maintained successfully. We have a very large footing right here, which is 2.4. This is quite large. We need to know where we have that large footing. Should be at the staircase provisions. Okay, so now here we go. Now these footings are being designed top and bottom, but I want to use one to show you how you can change it to only bottom reinforcement. If you double click in this provision of here, you have sixth. Here you have this footing, part footing dialog, and then if you come to 3D and then you use the right mouse button to update this, you can see that your footing is designed top and bottom. All right, so if you want it to just only be bottom, what you do, come to rebar provisions and uncheck this rebar successfully to have it only the bottom bar. Okay, so you can check the design and then make sure all of the requirement has passed based on the code of partics you've used. Okay, and then you can see the spacing here, and then the reinforcement is 16 diameter right there. After which, click on the OK. So what I've just done to this first one is what we're going to do to all of the footings to have them designed as a single or bottom only reinforcement. Okay, click on the OK options from here, or you can see detailed design report right here. You print it, click right there. Here we go. We have all the footings being designed just like this. So at this staircase provisions, we have a very large footings right there. Okay, so that is not a problem. That will be implemented successfully. Okay, so now you see at this point we have done with all the necessary settings. We have done with all the necessary designs of all of the structural elements in this structure, and I've also shown you how to optimize this. Okay, now what we'll do is we go, before we print, let's go to beams settings. We'll do some settings with the beam so we can have a good detailed beam. Successfully click in these provisions and come to the drawings, and then over here we want the beam labels to be underlined. You can uncheck so it won't be underlined. We want it underlined. For the sections, we want only one section on each span. Okay, and then we want to restart sections labels in every axis. All right, so now if you scroll to these provisions here, well, we use the struct style annotation. Uncheck that, so we have this struct style annotation right there. All right, so you can print the total quantities of the reinforcement. You can also draw links. If you click this, it's the links label will be in between. Okay, so but we want to move it to the, we can print this bar layers informations as well. Okay, bar layer information like layer 1, okay, bottom and top. All right, so we can use these provisions also. But there's one options I would like us to use: draw links, extend by size. I will check here. No, can go by that. Okay, that is good. All right, there is one. this shift. No, we don't need that. I think this is good for now. And then you can see print link label inside the beam. So if we click right here, this link label will print it outside. All right, so most of the time I prefer printing it outside instead of inside the beam, so that it will not put my drawings in an unkept details. All right, so I think that is good. For the sidebar, everything is nice. For the dimensions, everything is good. So this is basically for the beam settings. All right, you go to the foundations. So all the settings I've done here is applicable to all the beam, both the foundations and the floor beam successfully. Okay. All right, so we can also go to the label provisions player here and bring these details of this beam out just like this. So this is good. Click on the OK options, and then here we go. All right, everything is nice. Click on the save option now. So you can drop your comment in the comment section if you have said it, other things you wouldn't understand in this full complete building design, considering real life projects like this. Okay, drop your comment in the comment section. Do not forget to like and subscribe. Want to proceed to produce the design drawings. So for the design drawings, you just have to navigate to the drawings and report right there. And so we proceed to the Prota detail. So just click on the Prota detail 2026 version. So you just have to give it some time to load and then take these drawings to Prota details. So here we go. We are going to be using this auto generate details options. And then we click on draw option and pick in space. Give it some time to draw all the details of the structural element as well as staircase. Then you see the bar bending schedules. So from here we have the details drawings. So we have 3 set of staircase, and then there's the first, second floor, and then the last floor stair detail. So you can see the stair reinforcement selected. We have whitened right there. We also have all of the details for the staircase. Right, this is the foundation details. You can see it is double reinforced. I changed only this one. This is single reinforced, which is the one I've changed. So use that same process to change it successfully. Okay, and then these are the beams and the beam details. All right, produced in ProtaStructure version 2025. So here we have the bar bending schedules. All right, so you can also be able to produce these beams story by story using these provisions successfully. Okay, these are the columns and these are the floors. All right, so this is the detail we need to edit in Prota detail, just like this. You can edit here successfully. We have all of the editing tools right there to carry out your editing successfully. All right, you can join our masterclass so we can teach you all of that. Okay, so for the stairway, we can see the options to actually generate staircase separately. So for instance, if you want to generate so these are the story beams from here. You can expand, and they have foundation beams as well. If you click on these provisions, you can see the foundation beam. So you can actually select on the foundation and right click, on this right click, so you can draw the foundation beam details from all axes you can use your preferred scale. You can insert a sheet. All right, so all of this you can do. Click on draw, and then once you pick in the space, so this will be drawn successfully and it will be organized in a sheet. You can also bring in your sheet from AutoCAD and then be able to use it to organize your detailed drawings using ProtaStructure 2026 versions. So we actually explain and teach all of that in our masterclass. Okay, so let's wait for this beam to be drawn successfully. Before, because we actually choose the options of a sheet, so it's taking time to prepare the sheet, as you can see. So it will actually prepare a sheet that will be enough for this beam to be arranged inside successfully, just like this, as you can see. Okay, so we have two sheets right here. So these are the power bending schedule for the beams, right? And then this sheet you can bring in your own, just as I said earlier, where you have your details for your company. Right, so this is how you can also produce your detailed drawings directly in a sheet, which I've shown you in ProtaStructure. Right, yeah. So from here, if you want to move these drawings to AutoCAD, it's as simple as getting to this export to DWG/DXF. Right click and click on export from here. So we see the name as drawing 1. We click on export. So this will open the directory where this drawing is kept. All right. So export is done, and then this is the drawing. Just double click on it and this will open AutoCAD automatically, and then take this drawing to AutoCAD. So if you're conversant with the use of AutoCAD, you can actually use it to edit your drawing successfully, put them in your title block, and then send it out for constructions. Okay. All right, so we minimize this, so this bring this detailed and essential tutorial to a stop. So if you are yet to subscribe to our channel, Soft Reason Academy, just have to subscribe and stay connected. Like the video, also share this video with our colleagues so they can be able to have a proper knowledge on how to use this program to fast track your structural analysis and designs of any kind of building successfully. All right, we stop here. Have a great day and see you in the next presentation. Bye for now.